Uh, Next part of the video is really we'll go round to the front end. And something you have to realize with Model 3 is that the best in the world is between 50 to 60 horsepower, 14,000 RPM, and that's really world class. Them motorbikes can cost around £25,000, £15,000 kit, and then that would maybe get you on the grid. So I've been trying to work with what I can and within the rules to the best I can. And one of the things I put on the front of this bike was a ZX636 radial calipered front end. Not a new front end, but there was nothing wrong with it. And these can turn around and take over 100 horse, the exact same way as the rear end. And this frame modified from the RZ LC days with the head strengthened and the rear end completely redone, different configuration. It can take 70, 80 horsepower all day long. And tubular frames is quite popular in the Moto Grand Prix classes anyway with Ducati and stuff and KTM. So nothing really different there. It's trying to use as much resources and stuff as I can and products I can as cheap to build the Model 3 because that's not where the emphasis really is on the technology. One of the things I want to show you was it's called a Dion device. Now something required in Model 3 is it has to have a brake guard. The biggest fault with modern brake guards is they come out from here and round and they don't allow you in the corner to put your hand out over the edge, which I tend to do when I'm leaning into corners, high speeds and stuff. I would tend to have my hand out over the edge. This here is the actual brake guard, but it works the opposite way too. So if somebody's coming past, actually it doesn't click the handlebars round. So this actually came from a Canadian story where a guy that raced there, his name was Michel Mercier, well, his son started racing, and I raced against his son, and in the 600 class, he had actually clipped the back of another rider with the brake, and well, I ended up a fatality, and we lost Max. So his father and a company got together, and they put this, and it's called a Dion device, ties onto the handlebar, but the biggest advantage is it's bi-directional. Stops this way, but allows it doesn't click. The next thing is this. Let's basically talk a little bit about the motor. The motor is a CBR 250R road bike. It also would be a CRF 250L. They're all the same engine. And them are the crash protectors and stuff that you can get for them. You can get slipper clutches for them. You name it, you can get for them. And why I went this way is it's got a unique unicam design so that it's open. It's got two cams, intake and exhaust, but it opens the two valves with the one cam. And I'll show you in a little bit if you want to see underneath. That there is a CRF 450F throttle body. And the other thing with this barrel and cylinder, I've done so many experiments with direct injection right through the side. Is it almost vacuum pressure? My biggest problem was I couldn't get the engine to accelerate right because there's not enough piston travel to allow me to inject the fuel fast enough. I could get it to idle, I could get it to come up to a little bit of speed, but I couldn't get it the whole way. But there is more potential there in the future for testing. The other good thing with this barrel is when you go halfway up, it ends up full of water, but the internal part of the barrel or cylinder doesn't touch the external. But halfway down it's solid, so then I was able to drill through without ever going in the water jacket. These are things that I had done for the experiment for the direct injectors. That's what I'd done. That was direct injector from an Escalade, I think it was, or a Corvette or something like that. And the holders and stuff are all in there where I'd machined them all up. So many experiments from that side. But the biggest thing I want to show you, and really the heart of this engine, is where it changes into the 3-stroke cams. Now anybody will know the 2 cams are done the same duration, same lift. They were designed from the 1 cam. I used the gears from the original CBR 250. Because before we go to that, the reason why I picked this engine, if this engine revs between 12 and 13,000 RPM with the gearing I have on it, that's 130, 135 mile an hour bike. But it has to get there. And the thing is, that's where you need to be for that class. You need to be over the 130, 135 mile an hour mark. And if we go back to the engine, the cams, I used this. And one of the reasons why I did so many experiments, but one of the one was doing it this way, where it's got dual lobes. So what it's doing is the valve train runs at the same speed as the crank, but the valves are opening every rotation. So the chain, the gear, all them things are rotating at the same speed. Nothing has changed there. But with putting the second lobe in there, I'm getting it to open every rotation. And both cams are done identical. I did these up on a CNC. Another really funny story. The material they were made from was out of the new 10-speed Ford output shaft transmission component. Basically, its material's got a whole different pile of properties, and then it was rough machined it on a lathe, drilled it, sent it out for heat treating, brought it back, hard turned it, and then profiled the cam profile and this orientation on a chuck, and profiled that out. And it worked really well. And that's the biggest heart piece of that motor. The next one what I want to show you, and it's something that has made it easy for me, is if we go up to here, you'll see that's a 10-inch Samsung e-tablet that comes with the ECU can send out a wireless or a Bluetooth signal. All you got to do is run a Bluetooth connection here into the ECU, which was actually the one I kept over from Ecotrons, runs back into the ECU, and that Bluetooth, how strong that is, I've been 100 feet away with this dash in my hand, and it's still running. Now, there's another big advantage. When you go and you run around and you do a lap or whatever, you can set any of these gauges to whatever you want. There's whatever the ECU can send out, you can pull it up here. And which is really good, you can pull up injection pulse widths, you can pull up ignition advance, you can pull up AFR, you can pull up so many things. And then you can switch it over into race mode dash, where you maybe only have water temperature and RPM, or a couple of things that you want to keep a look on. So it's really, really good that way. And I'll show you that connection coming up in a second. We'll see if we can get her to come alive. Takes a wee minute after I've powered it on for things, because I haven't actually had it on in a few days. But come off of that. We'll see. Want to walk you around a wee second. That's her. Another thing that's for the MotoGP class or for the racing class if they have to have a tail light put on there for wet conditions. I haven't put it in with a switch yet, but I'll get it done. And that's one of the lithium-ion batteries again for weight savings. And that battery has got so many churning umps, it's not even a problem. I can show you some of the stuff on the dash. There's your throttle coming up. Temperature. Air temperature, all them things. And then we'll see if I can get her to fire up. And that's her. Only other thing is I actually machined out the triple tree. And I machined out the triple tree. Our top yoke, which someone talk about. And then were Woodcraft 5-piece clip-ons. Again, where you can save money. If somebody has already done it, there's no point if it's cheap and it actually works well. You know, Woodcraft doesn't tend to be cheap, but it works well and it's cheaper than I could build it for. So I wouldn't waste my time on it. That's not for the development of this bike. The big key points in this motorcycle is it's the first I know of with that which could be in the future a 4-piece swing arm, double wheel bearing, potential for an electronically controlled torsion bar for increasing or decreasing swing arm. That's the first I've actually done with anything to do with wireless. And if any of you owned a Motec system, you will know how expensive a heads-up screen is. These Samsungs are £100. Motec or any of them other systems, that them screens are not cheap, nor can it give me that type of information. And then the big thing on the actual bike itself is there's some engineering differences. It's just a different way of doing stuff. But is it a new technical development? Not really. It's just a different way of me approaching it or putting it together. The biggest things, as I said, that I haven't seen is that type of swing arm. And then the one with the engine is a 3-stroke engine. And it needs a lot of development because the problem I've had, again, is back to that electronic side. And it's hard to lay blame because it has driven me round and round trying to find real issues that I switched the engine back to a 4-stroke to actually do some testing, and when I get that finished, then I'll switch it back to the 3-stroke motor, which I can do within half an hour. Again, okay, this is the Ulster GP3 machine, and thank you for watching.